Now that I've completed the 3 main steps in Xpress, I've added fixtures, defined the load to be applied, and specified the material for the study, we can now run the simulation. When you first arrive at the Run screen, SimulationXpress asks you if you would like to proceed using default settings. For your first simulation of any given test, the default settings are usually appropriate. However, these settings can help you fine-tune the calculated results. Let's explore this further. I'll click the Change Settings button in the task pane. Without getting into too much detail, in order to run the analysis, SimulationXpress needs to approximate your part with simple triangular volumes called elements. The sum of these elements is known as a mesh, and the process of creating the mesh is called meshing. Xpress lets you control the size of the elements in the mesh by clicking the Change Mesh Density link. In general, smaller-sized elements allow the part to deform more naturally. Larger elements can over-stiffen the part. Consequently, as the element size is reduced, across subsequent studies you might perform, you may see both deformation and stress increase or become more accurate. However, after a certain point, further reduction in element size ceases to provide any benefit in accuracy. The mesh using this element size represents what's called the converged mesh. Remember, reducing the element size means more elements are required to complete your mesh, meaning that SimulationXpress will have to work harder and longer to complete the calculations. Making the size too small at the start for no reason isn't always the best approach. Even highly experienced analysts can't predict exactly what element size will result in a converged mesh, and simply dragging the element size slider all the way to fine doesn't guarantee it either. If more accurate stress results are important to you, you're encouraged to repeat your simulation with at least 2 mesh sizes, usually the default, and a size approximately half the default, and examine the change in stress and displacement. If the results of interest don't change much, you can consider the mesh converged. If they change a lot, you may want to run a 3rd iteration with a smaller element size. The meshing process can be quite complicated in traditional simulation programs, but it is completely automated for you in Xpress. In the complete version of simulation, the convergence process is also automated, and the most accurate and efficient element size can be found without any intervention from you. If you're trying to use Xpress to determine stress levels that compare directly to testing, convergence becomes critical, and you may want to consider the automated tools in SolidWorks simulation. On the other hand, if your goal is to compare iterations and design changes using relative changes in stress or deflection are most important, the manual tools in Xpress will suffice, and the default setting is usually appropriate. For this example, I'll leave the settings recommended by Xpress, so I'll press Reset. I'll click Next in the wizard to proceed. All that remains now is to click Run to process the simulation. When I do, SimulationXpress will calculate the stresses resulting from all of the properties I specified up to this point.